Okay, let us see another example. I'm almost done with the sketching, but we are going to go through together. Uniform rods AB and BC with equal masses of 30 kilograms and equal length are smoothly jointed at B. So meaning we have a joint at B. So this one now is going to be AB, then BC. Now we hear the word uniform. It means that the weight is going to act in the middle, or is going to occur in the middle, or the center of mass is in the middle. So if this is AB and this is uniform, it means that the mass is going to act in the middle. So the masses are of 30 kilograms. So meaning here to get the weight, we get the mass times G. So this will be now the mass which is 30, then times G. Even this side, they are having equal masses. So this one is also going to be, I want to say this is going to be my middle part. It's going to be now also 30 times G with is. Okay. And smoothly jointed at B as you say there. So you don't have the length. So you say let's to L be the length of each rod. It means that if this one is uniform, it means that this weight is going to divide that into two equal lengths. So if this is 2L, then this is going to be L and this is going to be L. So that from here up to there we have 2L. That is the idea. So this one is going to divide it into two equal parts. The same idea here. This is going to be L and this is going to be L. From here to here to be to L. And the A is free hinged at a rough horizontal surface. So this one is hinged, means that it is in contact with the surface. So expect reaction at A. And C also stands on the same surface. So it means that we expect reaction at C. Once there is contact, there is reaction. As simple as that. Okay, so these two are rough, meaning we are going to expect some friction. So we are going to be having friction at A, which is going to be mu R A, because they are telling us that stands with coefficient of friction mu. So meaning this surface is the same, means that the friction is going to be having the same coefficient of friction. So friction here is going to be different from friction here, but all of them are having mu because they are on the same surface. So here you're also going to be having some friction at B, which is going to be mu times the reaction at C. Sorry, the reaction at C, which is RC. With the is, then you continue. If angle BAC, so they are giving us this angle as 60 degrees, okay? And this is about, is that on the point of slipping? Fine. Slipping means it's about to either slide, so on. So support C is at the point of slipping. So meaning it's just in equilibrium. Okay. Remember, if this length is the same as this, it means that we are going to form an isosceles triangle. And for an isosceles triangle, two sides are equal. It means that even the base angles are equal. So even this is 60 degrees, like that. So basically, that's what we had. Now means that to get reactions, we said we take moments to get one of the reactions, or you can take moments here to get this, and take moments here to get this. So you can take moments, but we say take moments at both is a bit heavy, or it's a bit lengthy. That's why you resolve vertically upwards, and you get the equation letting this and this. Then after you take reaction at one, then you get the other, you substitute in the other equation as we are going to use here. But if the equation is not so heavy, you can take moments at both. So what we are going to do now, I think that's what we have. So we are going to resolve now vertically upwards. So resolving vertically upwards, this now is going to have the two RA, they are the ones going upwards, plus RC is going to be, this one is acting downwards. We have 30G plus 30G, because now our RA plus RC is going to give us 60B, and I call this equation 1. Okay, now you either take moments here or here, depending on the forces we have, but the forces are the same. So we take moments at A, then we shall get the reaction. If you take moments at A, you get the reaction at C. If you take moments at C, you get the reaction at A. As simple as that. So Let us take moments at A. So if you take moments at A, you shall get this reaction, but this is acting and clockwise. So now, to get those moments, that means we need these distances. So now, what we are going to do, we are going to first divide this, because this is isosceles, we divide it into two equal parts, like that. Then you call this N. Means that now I can get this. First of all, I have this angle. You see this angle when I construct this triangle here. This is going to be, we have this length, so we can get this because we have the angle. So you see that this is adjacent, so this one is going to be L cos 60. That's how you get that. Now, means that if we from here up to here, this is going to be the adjacent. So, remember, the other idea is from here to here is going to be 2L cos 60. So, if this is L cos 60, even this one is L cos 60. Or we say, this way always divide this distance from here up to here into two equal parts. So, if this is L cos theta, and then cos 60, this one is also going to be L cos 60. It is. So this one is always dividing this into two equal. The same idea here, we are going to be having this. You see, this is going to be, we have the hypotenuse, we need an adjustment. So it's going to be L cos 60. This one only, but we say this one divide this into two. So also this one is going to be L cos 60 degrees. With ease. No any struggle. Once you know that, places are going to be very easy. You know, the only thing you need to know, how do I get this length? Always this from here up to here is going to be the same from here up to here. If this is a uniform road, this guy. Anyway, after getting that, then you can take moments at A. Now, if I'm to take moments at A, I think you can see I'm going to be having moments at A. I'm going to be having this first one anti-clockwise. So, I'm going to be having RC, then times the perpendicular distance from here up to here. Shall get this L, this L, this. So they are going to give us 4L cos 60. It will be, now, all of forces from A, when you take moments at A, all of forces from A, their moments are going to be 0. Why? Because we say moment is given by a force times the perpendicular distance. So, from this A, the perpendicular distance from this RA is 0. And also those forces coming, you see this one is also coming to A. It's also perpendicular distance is going to be 0. So that's the idea there. Then after this one is going to act clockwise. And we say the sum of moments anti-clockwise is equal to the sum of moments anti-clockwise. So sum of moments anti-clockwise is equal to the sum of moments clockwise. So now clockwise we have first of all 30 then times this perpendicular distance from A. You see from A here we are having L cos 60. Then plus I come now to this 30 Now this is 30 then times this perpendicular distance from here up to here. I think you see this is going to be 1L cos theta, 2L cos theta, 3L cos theta. So from here up to here, 3L cos 60. So from here up to here is 3L cos 60 degrees. Once you know how to get these distances, the rest are going to be very easy, as you see. Anyway, what's common there? You see that we have many common things. First of all, cos 60 is common, so it's going to go divided by cos 60. Then you also have L common, L goes. So from here, it's that we have 4 RC equaling 2. This is going to give us 30 G. This is going to give us 30 G plus this is going to give us 90 G. And from there, so you are going to get 120. And so my RC is going to be 120 divided by 4 is 30 G. This is my reaction at C. Don't forget the G as my point. So from 1, now I ended at A. Reaction at A is going to be 60 G, and that's reaction at C, G minus 30 G. So my reaction at A is going to be also 30 G with ease. So you put in the D, 9.8. Okay. Reaction at the hint B. If they want to get this reaction, what you do now is separate this system. So this was before separation. Before separation helps us to get these reactions only. Now if you want to get other forces like reaction here at the hint, now you separate. If you want to get this friction, you separate. You get these bosons by separating. So now let us see separation after separating. After separating, now you consider the rod with the resisting number of forces. You see this, we have 1, 2, 3. This one 1, 2, 3. So they have the same, so you can take any. But it's always better to take this one. So me, I always take this. But you can take this, this is going to give you the same answer. So if I take that, now this is going to be my rod. If I take that, this is going to be my rod like this. So remember, our reaction is going to be acting this side at this point B. So now we resolve this into a vertical component, which we call Rx, and also resolve this into our vertical component Ry. The result of then a vertical. So now remember, here we had a weight which was acting. This weight was 30D. Now here I'm separating. This is the point I'm separating. So I'm separating this to this. So when we separate there, we have a reaction. Then here we had our point A. We had reaction there, which was Ra, and also we had our mu Ra here. So basically that's what we have. This was our L and this was our L. Now all we need, now if I base on this, is that if this is cos 60, it means that this is opposite now. So there that goes with sine. So this is the whole from here up to here is 2L. So this one now becomes 2L sine 60 degrees. That's now the height from here up to here. So we shall use it here. So this one is our L cos 60 degrees. And then this one is also L cos 60 degrees from there. Then the whole of this is 2L sine 60 degrees, the distance there. So after having that, the rest are going to be very easy. So we have just separated that. Now, after doing that, now we resolve horizontally and vertically. So resolving horizontally, you see horizontally, now we have this diagram. Horizontally, we have Rx equal to this. This one is going this side and this one is going that side. So it's that let me start with mu Ra is equal to this one going the other side, which is Rx. As simple as that. We have this, but we don't have that. So, meaning from here is that the Ra, we have our Ra there at degree. So, you can start my Rx is equal to 30 G mu. I call this equation 1. Then you also resolve vertically. Resolve vertically. Remember, our interest is to get this reaction. That's why we resolve horizontally and also resolve vertically. So that in the vertical resolving, this will be included. So resolving upwards, we have Ra. You see this Ra. Then it's the only force acting upwards. It's going to be equal to this one is acting downwards. 30G plus Ry. So remember, this system is in equilibrium. That's why we are saying they are equal. But our Ra is 30, so this is 30G equaling 30G plus Ry from here, implying that now my Ry is 0 Newton. So I have the vertical component there. Now to get the horizontal component, we can ably take moments at A. So taking moments at A, now we want to get this. So let us take it that you see that it's going to act anti-clockwise. Taking it anti-clockwise, now you see anti-clockwise, we have now this acting anti-clockwise. So we have now Rx times the perpendicular distance from A up to here is the same as from here up to here. So from here up to here is 2 L sine 60 degrees equaling 2. These ones acting downwards, we have, you see now these ones are acting now, for them, they are acting clockwise. That's why we said they are equaling using the principle of moments. So 30 D, then times the perpendicular distance from where I take moments. So you see this is a vertical force, its perpendicular distance has to be horizontal. So from here up to here, we have L cos 60. Then plus, we also have R or Y times its perpendicular distance from now here. This R or Y is this plus this, which is 2L cos 60 degrees. Basically, you are through. So, you see that, first of all, this is common, and that is common. That's what we have. But remember, our R, this is 0. So 0 times this, the whole of that vanishes. So, we have now Rx times 2 times sine 60 is root 3 over 2. Those are special angles equaling 30 times cos 60 is a half. So from there you can able get our Rx. So is that this one is going to cancel? So I mean this one has 15. So I have my Rx as 15D over root 3. It is, and that one is going to be in which you can by rationalize. It's the same as 15D over root 3 times root 3 over root 3. This will give us, this is going to give us 15 root 3 D over root 3 times root 3. So that our Rx from there, I think it's going to give us 5 root 3 D. You don't want something in the numerator, that's why I rationalize there. So after getting that, I think now they want us to get, they are telling us to find the reaction at the hinge. Now our reaction, as you can see, it's given in Rx, then the result as Ry in this direction. That's our R. So means that now we get the square root value C. So now this is going to be, now my R is going to be the square root of R, the horizontal component, and then the vertical component. This is going to be the square root of this one, 5 root 3, the whole square, plus 0 squared. And so my reaction is going to be now 5 root 3. Sorry, this is D. Root 3 D. Newtons, as simple as that. So basically that's what even these ones are in Newtons, please don't always forget. So that's what we have. Now, from there we want to get okay, so from there now we want to get the reaction. Remember, they want us in part C to get the value of mu. Remember from there we said our Rx is going to be equal to 30 D mu. So our Rx, okay, so either I can use this or N. Anyway, let me use this. My Rx is 5 root 3 equaling to D. This is D. D equaling 30 D mu. So it's that from there we can get, you see that this D is going to vanish. So it's that our mu is going to be 5 root 3 down over 30. And divide this beside, which you can see that our mu there is going to be, our mu is going to be root 3 over 6. And that will be our mu. So that's it, unless otherwise. So that's it. You can look through and see if there is, then you can correct that. So that's it. I wish you well.